Okay, so the next question that we have is the mean and standard deviation of 20 observations are found to be 10 and 20 respectively. So we have the mean and the standard deviation of 20 observations. We have 20 observations. We have 20 observations, meaning that n is equal to 20. And the mean of those observations has been found to be 10. X bar has been found to be 10. And the standard deviation, or sigma, has been found to be 2. Now it says that on checking it was found that an observation 8 was incorrect. And observation 8 was incorrect. And calculate the correct mean and the standard deviation. The correct mean, the correct X bar, and basically sigma. Calculate these two in each of the following cases. We want to calculate each of these in each of the following cases. So case 1 is basically if wrong item is omitted. If the wrong item, or let's just call it 8, because the wrong item was 8. If 8 is omitted, and case number 2, if 8 is replaced by 12. Okay. Now this question is tricky in a couple of respects, and but of course we can solve it. I happen to have spent some time on it, and it's not that complicated. It's not actually complicated at all. It's the same concepts that we have been doing so far. So you have 20 observations, so meaning that your n is equal to 20, your X bar has been found to be 10, your sigma has been found, which is standard deviation, has been found to be 2. Now here basically what we have found out is that an observation 8 was incorrect. And so now if I take out this observation 8, what happens to X bar and also what happens to sigma? That's what I want to calculate now. So since my n was 20 and my X bar was 10, now if I call basically if I want to, if I call basically in case 1, so the new basically to calculate, so basically you need to understand what you do, and you need to basically do something if you have to do it. Otherwise it makes no sense to basically to follow steps. Now what I want to calculate is I want to calculate X bar in the new situation where X is omitted. Now to calculate X bar, so let the new basically the new mean be, for example, Y bar. So then you have basically Y bar is basically by definition sigma of f of I, sigma of f of Y of I is equal to sigma of Y of I divided by sigma of f of I, as I goes from 1 to, for example, now over here you need to be careful because you're taking out one of your observations. So your n was 20, so now your n becomes 19. And let me write this properly. So your I becomes, your N becomes 19 because you're taking out one of your observations. That's the mistake that actually I did make. So your Y bar is equal to basically sigma Y of I divided by sigma F of I as I goes from 1 to 19, and over here as I goes from 1 to 19. Okay. Now over here I need to calculate my Y of I, or basically sigma Y of I. If I can calculate sigma Y of I, or if I calculate Y of I, then I can calculate sigma Y of I, and sigma F of I is already given to me. It's 19, so I can calculate my Y bar. Now the way that I can calculate sigma Y of I is that basically from here I know that my X bar is equal to 10, which is equal to basically sigma X of I as I goes from 1 to 20, and as divided by sigma F of I as I goes from 1 to 20, right? So what that means is that the new so now what I need to do is that I need to calculate let me see. Okay, so the way that you can think about this is that, of course, sigma X of I, we don't have it. Sigma X of I as I goes from 1 to 20, we don't have it. But we know that basically X bar is equal to 10, and sigma F of I is equal to 20. So I can write this as basically sigma X of I as I goes from 1 to 20 divided by 20. Okay, so that means that 10 is equal to sigma X of I as I goes from 1 to 20. This is not a part of this. So you can say that basically sigma X of I as I goes from 1 to 20 is equal to 20 times 10, which is equal to 200. So I know that sigma X of I as I goes from 1 to 20 is equal to 200. Now, based on this, you can calculate sigma Y of I, because I know that I have basically taken out 8 from basically my observations. That means that if I take 8 out of my observations, then sigma Y of I, if I take that as the sum of the new observations, sigma Y of I as I goes from 1 to 19 is going to be equal to 200 minus 8, which is equal to 192. So then over here I can write 192 divided by for example, sigma f of I as I goes from 1 to 19 is 19. I have 19 observations. So then if I divide 192 and divide it by 19, what I will get is 1 times 19 is equal to 19, 0. And then I have a 2 over here, 0, 0.0, and 0, so 0.1. And 1 times 19 is equal to 19, 1, so that's 10.1. 10.1. And of course I have done this calculation before. You will get a 0 after this, so you will come up with 10.1. That is actually the right answer. So that's how you can do this part. So that means that your y bar is equal to 10.1. Your y bar, which is basically the new, which is the new mean. The new mean is equal to 10.1. Now, the next thing that we want to calculate is basically sigma, which is the standard deviation. And to calculate sigma, I have seen something over here which is kind of new. Let me see, let me do this. Let me read this to you so that you understand it. You see, they have used a formula over here, I've never actually used in any of these videos. And they have written standard deviation, which is denoted by sigma, is equal to the square root of 1 over n times sigma of x of I squared as I goes from 1 to n minus 1 over n squared times sigma of x of I times sigma of x of I as I goes from 1 to n, and you raise this to the second power. And then over here you have basically, that is your deviation. Now if you want to know where this formula comes from, it actually comes from the, if you remember, we talked about the shortcut method. In the shortcut method, we said that, for example, we had a number of observations, and in these observations, basically, we had some x of i's, and these x of i's, and we had some f of i's as well. And these x of i's and f of i's, if you want to calculate deviation, the ordinary way you have to calculate, for example, sigma is equal to the square root of, for example, 1 over n times sigma of, for example, f of I times x of I minus x bar whole squared as I goes from 1 to n. And then you have to basically multiply all of, basically first calculate your x bar, subtract it from your x of I, each x of I, multiply f of raise that to the second power, multiply f of I by that, and then take the sigma of that divided by n, you will get, and take the square root of that, you will get your sigma. Now this was a little bit problem, a little bit trouble, so we came up with the basically the shortcut method. So we said that in the shortcut method, what we did was that we said that basically we had all of these x of i's and f of i's, and we defined something called A, which was the assumed mean of the data, of all of of all of the observations. And then we had something called H, which was basically the class size. Meaning that, for example, if your classes went from, for example, 10 to 20, 20 to 30, for example, 30 to 40, and so on and so forth, then 20 minus 10 is equal to, for example, 30 minus 20 is equal to, and so on and so forth. And that is equal to all equal to 10. So that is your class size. So then we had this class size over here as well. And so we defined basically y of I as basically x of I minus a, subtracted the assumed mean of the data from x of I and divided that by h to make basically the number smaller. This was our basically y of I. And then also we said that basically y bar was equal to a plus h times x. I'm not sure about this. We said that, x bar. We said that x bar is equal to a plus h times y bar, for example. So that way we could calculate basically y bar over here, x bar over here, and then that way we could calculate y of I, and then we could calculate the whole thing. But the important thing here was that basically we could calculate standard deviation, which was basically h over n, and this was basically taken from the formula that we already had for standard deviation and variance, and that the whole story there. So we had h over n times the square root of basically n times sigma of f of I y of I squared as I goes from 1 to n, minus basically sigma of f of I y of I as I goes from 1 to n, and we squared this and took the square root of this whole thing, and this became basically standard deviation. Standard deviation. Now we had this standard deviation here. Now what basically the way that you can find this formula from this formula is that, well, I would assume that, for example, you could take if you take the assumed mean of your data as 0. First of all, if I take h as 1, if I take basically h as 1, meaning that the class size is 1, you can remember the instances where basically we took h as 1 because there was actually no number upon which all of those numbers could be divided. So we took h as 1 so that all of those numbers were divisible by 1. And so you can take h as 1, and then you can take a as 0, and you can take a as 0. Then basically what happens to your y of I over here becomes basically x of I minus 0 divided by 1, which is equal to x of I. That means that your y of I becomes x of I. And so based on that, I can write, for example, sigma is equal to h is equal to 1 divided by n, and I write all of these in lowercase n, divided by n times basically n times this sigma of I is equal to 1 to n, and well, this becomes x of I squared because y of I is equal to x of I. So this is f of I x of I squared minus sigma of minus sigma of f of I x of I as I goes from 1 to n whole squared, and take the square root of this. And then what you can do is that you can basically take this 1 divided by n inside the square root function, meaning that raise that to the second power to take it inside. So if I raise this to the second power, it becomes basically 1 over n squared. Now if I multiply it by this first term over here, 1 over n squared times n, these two would cancel out. You would be left with 1 over n. You would be left with 1 over n here. So this would be equal to basically the square root of 1 over n times sigma of f of I x of I squared as I goes from 1 to n minus sigma of, I'm sorry, there is a 1 over n squared over here, 1 over n squared here, and then times this whole thing, which is the sigma of basically f of I x of I as I goes from 1 to n whole squared, and take the square root of the whole thing, right? Take the square root of the whole thing, and that is standard deviation, which is nothing but the formula that I have here. You can see that it's n times, no, sorry. It's nothing but the formula that I have here, 1 over n sigma of x of I squared. And of course, again, if you have the kind of data where, for example, you have, for example, these 20 observations, of course, you know that you can just simply forget about your f of I, because the frequency of each of those observations becomes 1 and 1 and 1, so you don't have to write that anymore. So you can write that as the square root of 1 over n sigma of x of I squared as I goes from 1 to n minus 1 over n squared times sigma of basically x of I as I goes from 1 to n whole squared, and that is equal to basically standard deviation. And that is nothing but the formula. That is nothing but the formula that I have up here. 1 over n, there is actually 1 over n. Okay, so there is 1 over n sigma of x of I squared minus 1 over n squared times sigma of x of I whole squared. And you take the square root of the whole thing, that becomes sigma. So this way you can calculate. This way you can calculate standard deviation. Standard deviation. Now the good thing about this method, is that over here, first of all, you don't care about the class sizes. The class sizes, you have taken them as 1. And you don't care about your f of i's. You have just simply taken them as, you have forgotten about them altogether. Of course, you haven't forgotten about them. You can, of course, omit them. So then there is no class size. The only thing that you need is is y of I squared, or x of I squared here. And then over here, the only thing that you need is sigma of x of I, and that way you can calculate your standard deviation, this exact formula. I think that's how they've gotten this formula. Otherwise, there is, I mean, as far as I know, there is no other way that you can get that. Now let's go back to the example and see what we have here. Okay, so and then what they have done is that they have written this formula as basically they have written this formula as the square root of 1 over n sigma of x of I squared as I goes from 1 to n. And as you can see over here, this is nothing but when you say sigma of x of I as I goes from 1 to n divided by n, that is equal to x bar. So now if I square this, and if I square this, if I square these two, then this will be basically x of bar whole squared, or x of bar squared. So I can write this as minus basically x of bar squared, right? So that is basically the formula that you can use. That is the formula that you can use in order to calculate standard deviation. I'm sorry, not here. That is the formula that you can use to calculate standard deviation. Now, what we can do over here, we said that basically so if I over here, we said that the incorrect basically standard deviation was 2, right? So if I write over here the incorrect standard deviation, which is equal to 2, and over here that if I can write 1 over 20 because the number of observations were 20, and over here I can write sigma of x of I squared as I goes from 1 to 20 minus basically x of bar squared, and x of bar squared was here equal to 10. As you can see here is equal to 10, and these are all the wrong values. So that is 10 squared, which is equal to 100. So I can write this as then basically raise both sides of this equation to the second power. I'll get 4 is equal to basically 1 over 20 times sigma of x of I squared as I goes from 1 to 20 minus 100. And that's actually one of the things that you need to have in order to calculate your sigma, basically your standard deviation. That's actually one of the things that I did need over there on the board. I couldn't get to this thing, and I thought there was no way to do that. So that's actually one of the things that you need to have in order to calculate your standard deviation. The correct standard deviation, of course. So then I can say that basically that is, if I take this 100 to the other side, this becomes positive 100. 100 plus 4 is equal to 104 is equal to 1 divided by 20 sigma of x of I squared as I goes from 1 to 20. And then if I multiply both sides by 20, I will get 2 times 104 is 208. 208, and a 0 is equal to sigma of x of I squared as I goes from 1 to 20. So that is something that we can use now in order to calculate basically the standard deviation. Of course, this thing over here is the incorrect value. Of sigma x of I squared as I goes from 1 to 20 based on incorrect inputs. Based on incorrect inputs. Okay. So now we have what we need to have in order to calculate the correct basically value for standard deviation. Okay. Okay, so now what I can do, I can use the same formula in order to calculate the actual value of basically standard deviation. So the correct standard deviation, standard deviation is equal to basically sigma, which is equal to the square root of, what was the formula? 1 over n sigma of x of I squared. 1 over n sigma of x of I squared as I goes from 1 to n minus x bar whole squared, right? Now the only thing that I need in this formula is the value of x bar that I have already calculated somewhere over here, which we call basically the new mean, which we called y bar. So x bar, we can call it 10.1 over there. So x bar, we can call it 10.1 here. So 10.1, the value of x bar, I can use 10.1 here in order to calculate sigma. The only thing that I need to calculate is sigma x of I squared, and that is possible if I take the value of sigma, basically the value of sigma, basically the value of sigma x of I squared as I goes from 1 to 20 was equal to 2080. So based on this value, I can calculate the correct value for basically for the value of sigma x of I squared. So I can write sigma x of I squared as I goes from 1 to 20, and this is the incorrect value. Let me write this, for example, this way. Let me write this, for example, incorrect sigma of this. So that is basically in this sigma of I squared, we have basically, what is sigma of x of I squared? It is basically so if you expand sigma of x of I squared as I goes from 1 to 20, that would be x of I squared plus, x of 1 squared, for example. That would be x of 1 squared plus x of 2 squared plus x of 3 squared plus x of 4 squared plus all the way up to x of 20 squared. So now in order to, and now that I have taken, what I have done is that I have taken this 8 out, meaning that the actual value of x of I squared would be, I could write it as just 8 squared I have to subtract from this. That's the only thing that I have to do. Meaning that the correct value of sigma of x of I squared as I goes from 1 to, of course, 19, not to 20, is going to be equal to basically the same sigma x of I squared that I had, which was 2080, and this is the correct value. The correct value, 2080 minus basically 8 squared, because each x of I is raised to the second power. So 8 squared is equal to 64. So 2080 minus 64 is equal to basically, this is a 7, this is a 10, so 10 minus 4 is equal to 6, and 7 minus 6 is equal to 1, 0, and that's 2016. That's 2016. So over here what I can do is that I can write sigma of x of I squared as I goes from 1 to 19 is equal to 2016. So now I have the value of x of I squared, I have my n, I have x bar and everything that I need. So now I can calculate my sigma. So I can calculate my sigma. And my sigma over here is equal to the square root of 1 over n, which is 1 over 19, times sigma of basically x of, sorry, no, there is no such thing anymore. So I have basically sigma of x of I squared as I goes from 1 to n, which is equal to 2016 minus x of bar squared, which is 10.1 into the 10.1 raised to the second power. And so if I calculate this thing, that will be basically the value of sigma when you take that 8 out. So let's calculate this. So you have 2016, and you want to divide it by 19. Okay, so I actually did make a mistake here. I accidentally put a multiplication sign here and I got the whole answer wrong. But if you actually do go through this calculation, what you will get is basically 2.02. What you will get is 2.02, which is very close to, or 1.99. It's been given in the book. In this solution, I'm getting a value 2.02. So that is the value of your deviation, for case 1. Now we need to go back and basically solve case 2. Okay, so then the next part of this question is basically, basically you had the mean and standard deviation of 20 observations. So you had 20 observations here. N is equal to 20 observations. The mean of these observations was 10, and the standard deviation of these observations was 2. And then basically on checking, we found that an observation 8 we found out that an observation 8 was wrong or incorrect, meaning that it had been counted as a part of the observations incorrectly, And so based on that, then all of these calculations were done, and then we got the x bar, and we got the sigma, and we got also the n, and so on and so forth. Now, what happens to x bar and sigma if basically what happens to x bar and sigma if 8 is replaced by 12. Now, in order to solve this problem, let me think about it for a few moments, and then I'll come back and we will solve the problem together. Okay, so now to solve this problem, I need to come over here. Now to solve this problem, so we said that basically we had 20 observations, x bar was equal to 10, sigma was equal to 2, and we found out that one observation, 8, was wrong. So we switched this 8 with a 12, meaning that we took the 8 out, and we instead of that we used the 12 in the observations. And then the question that we wanted to answer is what happens to x bar and sigma? How will they change if we switch 8 with 12, or if 8 is replaced by 12? Now, to calculate basically your the new x bar, let the new mean be basically y bar. Then y bar is going to be equal to basically sigma of y of I as I goes from 1 to 20 over sigma of f of I as I goes from 1 to 20. Now sigma of f of I, we already have it. Sigma of y of I, we don't have it, and we need to calculate it. Now, so, and to calculate sigma of y of I need sigma of x of I. So I'll tell you what I mean by that. So if I use the information that basically x bar is equal to 10, then I know that if x bar was equal to 10, then what that means is that basically sigma of x of I as I goes from 1 to 20, for example, divided by sigma of f of I as I goes from 1 to 20, that was equal to 10, because this is basically the definition of x bar, sigma of x of I divided by sigma of f of I as I goes from 1 to 20. That was equal to 10. Now that basically means that sigma of x of I as I goes from 1 to 20, and sigma of f of I was equal to, over here it was equal to 20. So I can write 20 here is equal to 10. And so what that means is that sigma of basically x of I as I goes from 1 to 20, that is equal to 10 times 20 is equal to 200. So that means that originally the numbers that we had, which included also this 8 which was put there by mistake, the numbers that we had, or the observations that we had, the sum of those observations was equal to 200. Now what I need here is the sum of the observations when the mistake is taken care of, meaning that when basically x is taken out and 12 is put in instead of that. So that means that now that I have sigma x of I can say that the new sum of observations, or sigma y of I, as I goes from 1 to 20, is going to be equal to this sum, which is sigma x of I, as I goes from 1 to 20. And then you want to take your 8 out, minus 8, and then instead of that put a 12 there. So that's minus 8 plus 12. And of course this is just sigma of x of I, and this part is not a part of sigma, of course. So what that means is that this is equal to sigma of x of I as I goes from 1 to 20, and 12 minus 8 is equal to 4. So that means that if I take my sigma x of I, which was equal to 200, take that and add 4 to it, I will get my sigma y of I, which is equal to basically 200 plus 4, which is equal to 204. That means that sigma y of I, as I goes from 1 to 20, is equal to 204. This is the sum of all the observations when you take the 8 out, and instead of that you put in a 12. And now using this I can calculate the new basically mean, which is y bar. So the new mean, or basically y bar, becomes y bar is equal to sigma of y of I, as I goes from 1 to 20, divided by sigma of f of I, as I goes from 1 to 20, which is equal to sigma of y of I, we said, is equal to 204, and then sigma of f of I was equal to 20. Basically we had 20 observations, we took one out, basically we had 20 observations, we took an 8 out, and instead we put in a 12. So that means that we haven't added anything or subtracted really anything, because we have taken one out and then we have put one back in. So this remains basically 20. Now basically 204 divided by 20 is equal to 10, and this is 102, and this is 51, 51. This is 51, and this is a 5, and 51 divided by 5 is equal to 1 times 5 is equal to 5, and 0, 1 remainder, and 0, then I have a 0 here, and 2 times 5 is equal to 10. So that's 10.2. 204 divided by 20. 204 divided by 20 is equal to 10.2. So that is your y bar. So that means that then y bar is equal to 10.2. Now the next thing that we want to calculate is your standard deviation. Now the standard deviation, we said that we found a new formula in this video. We found a new formula which was we said that basically sigma, we could write it as the square root of 1 over n times sigma of x of I squared as I goes from 1 to n minus x bar squared. That was basically sigma, or standard deviation. Now, previously what we had, or originally what we had in our data, we said that sigma was equal to 2. We said that sigma is equal to 2. So that means that 2 is equal to 1 over the square root of 1 over n, which is 1 over 20. The number of observations was 20. Sigma of x of I squared as I goes from 1 to 20 minus x bar squared. Now x bar is over here equal to 10. So that is 10 squared, which is equal to 100. Which means that basically if I raise both sides of this equation to the second power, I'll get 4 is equal to 1 over 20 times the sigma of x of I squared as I goes from 1 to 20 minus 100. And then if I take this 100 to the other side of the equation, I will get 1 over 20 times sigma of x of I squared as I goes from 1 to 20 is equal to 100 plus 4 is equal to 104. Is equal to 104. Now if I multiply both sides of this equation by 20 to get rid of this fraction here, I'll get 104 times 2 times 2, and it's 0 over here. 2 times 4 is equal to 8, 0 and 2, 20, 80. So 100, so that this would be 20, 80, and this will be 1. So I can say that then sigma x of I squared as I goes from 1 to 20 is equal to 2080 or 2080. So, and this is sigma x of I squared. Now if I want to calculate basically the standard variation related to the data when we take this 8 out and then instead of that we use a 12 in our observations, then of course I can still use the same formula. I can still use this formula, but then I need to use the correct x bar and the correct sigma x of I squared. Otherwise I wouldn't get the right answer, of course. So the correct x bar and the correct x of I squared, the correct x bar would be, of course, y bar, because this is the mean of the data when we took care of the problem. And then we have to take care of the problem in the case of sigma of x of I squared as well, right? So now this x of I squared, how do we take care of the problem here? We need to basically, if I'm going to call the new sigma x of I squared, I'm going to call it sigma basically y of I squared as I goes from 1 to 20, and then basically a few things need to happen here, meaning that basically I'm going to need to take this basically from sigma x of I squared. So you know that basically sigma x of I squared, if I were to expand it, I would have to write sigma x of I squared as I goes from 1 to, for example, 20. That would be, for example, x of 1, for example, squared plus x of 2 squared plus x of 3 squared plus all the way up to x of 20 squared. Now 8 was somewhere over here as one of these observations, so I have to take it out, and of course it has it, as you can see, 8 was basically in the form of 8 squared in here, so I have to subtract 8 squared from this sum. So I need to subtract an 8 squared from this sum, and then instead of that I need to add a 12. To add a 12, I need to add the 12, but add 12 as 12 squared, because this is sigma x of I squared. So I need to add a 12 squared here. So that means that the new sigma x of I squared, which becomes sigma y of I squared, is equal to sigma x of I squared as I goes from 1 to 20, and I subtract an 8 squared from here. Of course, this is only this part is being operated on by sigma. So I take basically an 8 squared out, and then instead I add a 12 squared in. So what that means is that then this is equal to sigma of x of I squared, which is equal to basically 2080, and 12 squared is equal to 144, 8 squared is equal to 64. So if I subtract 64 from 144, I get 0, and then 14, that's positive 80. That means that I have to add 80 to this, which is equal to 2160. So that means that then sigma of y of I squared as I goes from 1 to 20 is equal to 2160. And now we can calculate sigma from using this formula. So I can write basically sigma. I can write sigma over here or basically sigma of a variable y, or the new sigma basically, is equal to the square root of 1 over n, which is, again, I still have 20 observations there, and then we have the sigma of y of I squared as I goes from 1 to 20 minus y bar squared, which is equal to basically the square root of 1 over 20 sigma of, basically there is no need for sigma here. Sigma of y of I squared is equal to 2160, and you need to subtract from that y bar squared. Y bar squared is 10.2 squared. So 10.2 squared is 102 times 102 and 2 decimal places. 4020 and 0, and then 102. Get 40401, and 2 decimal places is 104.04. 104.04. Now let's calculate this. Let's see what we get. So 2000, you can divide, basically simplify this 0 with this 0, and 216 divided by 2 is 108. So this part becomes 108. 108 minus 104 minus 104.04, which is equal to basically 7, 9, and 10. And so basically 10 minus 4 is equal to 6, 9, 3, and 3.96. 3.96. So that is the square root of 3.96. Now the square root of 3.96 is the same thing as 3.96. So 1 times 1 is equal to 1, subtract 2, and decimal point, 1 plus 1 is equal to 2, and then I bring down 96, so 29 times 9 is equal to, of course I have done this calculation, I already know the answer, otherwise I would have to search. So 9 times 9 is equal to 81, 8, 18 plus 8 is equal to 26, right? 18 plus 8 is equal to 16, 26, so that's 261. 261. So if I go for 9 times 29 times 9 would be 261. If I subtract, I'll get a 5. 6 minus 9 minus 6 equal to 3. 2 zeros here, 2 zeros here. 29 plus 9 is equal to 18, 38. So 38 over here, and 38, so you have 380 times 10 times 309 times 10 times 380 is equal to 3,800. So I think 8 times 388 times 8 is equal to what? That's 2400, 640, 640 and 64. So you have 401 113104, and 9 doesn't, I have checked this, 9 doesn't work here, so you have to go with 8 and 8 here, and you will get some 31, for example 3104, and you will get some remainder here, so you can take this as 2.0, which is equal to 2.0. So this is basically, this is your standard variation of your data when you take the 8 out and instead use a 12 in your observations. So that is that, and so your y bar is equal to 10.2. Your y bar is equal to 10.2, and your sigma becomes 2. Yeah, the answer that I have in the book is 10.1 and 1.99, which is, I'm sorry, 10.2 and 1.98, which is, well, kind of the same thing. Now I think I'm going to end this video here, and we have 2 more questions left, 6 and 7, that we will do in the next video. So I'll see you in the next video.